Buongiorno, baddies. Welcome back to another video. Today's first question is, how many digits are in the decimal expansion of 10 to the power of 30? As I said in a previous video, the way to calculate how many digits is 1 plus the power of 10 that it's being increased to when you're using scientific notation. So basically, this is 1 plus our b here is 30, so it has 31 digits. That's simple enough, but it gets slightly more complicated as we go on. Moving on to problem number 2, how many digits are in the decimal expansion of 2 to the power of 30? No one's going to be, well, some people might just have a living calculating this. Of like, oh wait, so 2 to the power of like 5 million is, yeah, I got you. But the majority of us doing math contest problems probably aren't that skilled. So we are going to use a different method. Because if you guys know, like, say they're like land points, like trail markers. Like, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 10 is 1024. That kind of stuff, like the stuff that's easier to remember so you can make it to bigger numbers. And 2 to the power of 10, to the power of 3 would be equivalent to 2 to the power of 30th by applying the 3 into the inside of our number. So using that idea of that, then we can find, like in some previous videos, I said like the greater than or equal, like the greater than but less than method for like fractions on how to see which one's bigger. This one uses the same method, but not for the same reason. So we know that 2 to the power of 10 is 1024 to the power of 3, right? That is obviously going to be greater than 1000 to the power of 3, just in sheer number size. But it's also going to be less than 2000 to the power of 3, also because of sheer number size. 1000 to the power of 3, however, it's going to have 9, because when we expand it out, it's going to be like, this is 1000, right? And you're going to multiply that by 1000, and then that by 1000 again. So here we have a whopping 9 zeros, but this has 10 to the, this number itself has 10 digits. And now that we look at this number, because it has 10 to the power of 9 zeros, and there's always our little a in the front. And now we look at 2000, and 2000, you might be like, oh, it's going to be a ton bigger than 1000 to the power of 3. It technically is, but it doesn't exceed that much. So basically, we can break this down into 2 times 1000. So then we multiply the 2 and the 2 to the power of 3, which is 8, and then the 1000 to the power of 3, which we've already calculated this monstrosity. But that isn't enough, and 8 isn't enough to add another 0 onto the end, because this number would basically be like our 1000 number, but with an 8 at the front. And this number also has 10 digits. And since 1024 to the power of 3 is set in the middle of these two numbers, that means that it's also going to have 10 digits. So the answer is 10. Moving on to problem number 3. This kind of calls for the 2 that we just used in the front, and it's slightly more complicated than the other 2. Yes, even than 2 to the power of 30. Because no one goes around memorizing powers of 5, like even less than the people who go around memorizing powers of 2, mostly because it gets bigger really, really quick. So when we are dividing to powers, so 5 to the power of 30th, which is what we're solving for, it's equivalent to 2 to the power 30th multiplied by 5 to the power of 30th is equivalent to 10 to the power of 30th. So using that same idea, that means that 10 to the power of 30th divided by 2 to the power of 30th is also equivalent to 10 to the power of 30th, 5 to the power of 30th, sorry. But we can utilize this. So you might be like, wait, but like, doesn't that like literally do nothing? But that also like tapes back to our previous 2 problems. Since now we know that the digits in the decimal expansion of 10 to the power of 30th is 31, and the digits in the decimal expansion of 2 to the power of 30th is 10, that means that, well, we can basically use that. So think about it like if we're dividing. So, well, 10 to the power of 30 is just a bunch of zeros and then like a 1 in front. But there are there's 30 zeros here. And the 2 to the power of 30 has 10 digits. So let's just say it's like A to like B. And there's 10 digits in total. When we're trying to divide a number, this number, since it's greater than 10 to the power of 9, it's going to start at the 11th digit of our humongous 10 to the power of 30th, because the front ones, we're not going to divide a 10-digit number into a 9-digit number, right? Like, that's going to end up with a decimal, and, well, that's going to end up with a less than 1 decimal, and 5 to the power of 30th is not less than 1. So we're going to have to start at a number that is going to be greater than this number, or else we're not going to be able to divide it and get a positive number. Well, it's positive, but like a whole number that's also big, like 5 to the power of 30th. So if we start at the 11th digit, that means that we have this whole this left expansion. Since these 10 digits are already taken up, there's like we can't argue for them anymore because this has already taken them up for the first one. So we have this much space for the quotient. And since 10 to the power of 30th has 31 digits, and our good old 2 to the power of 30th took up 10 digits, you can think of it like that. That means that we have 21 digits to create our 5 to the power of 30th in this little area. Which, if you think about it, isn't actually very little at all, but... So that means that 5 to the power of 30th has 21 digits, because that is how many digits are remaining after 2 to the power of 30th ate up a lot of it. So, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new. And I will see you guys in the next one. Goodbye.